Welcome to this lesson on constructions. Constructions, essentially in maths, are where you have a pair of compasses as shown, a pencil and a ruler, and then you have to create things. You might create shapes, you might create bisectors, which is what we're going to be looking at. We're going to look at the main ones at GCSE, and then we'll look at some of the things that you can do with that. And it's incredible what you can create. It looks really amazing. Now, I've got to say as follows. There's something that underpins a lot about what we're going to do. And the first thing is that circles. Circles underpin what we do because when you go around with your compass, you're creating a circle. And the other thing is the rhombus. So a rhombus has equal lengths, and its special property is that if you draw the diagonals in, then they will bisect each other at 90 degrees. I.e., we've got this line from C to the middle here. That is exactly the same length as the middle to B. And the same well, it's not the same, but A to the middle is the same as A to D. So bisect, and they bisect 90 degrees, so we say they're perpendicular. That is going to underpin what we're doing, and I'm going to talk about that as we go along. Right, let's have a go at the first one. You might have done this before, you might not have. So construct the perpendicular bisector of the line below, leaving all construction lines. Really important to not rub out any of your construction lines. What this means is I somehow want to draw a straight line going down like this that splits the line into two. So these are equal lengths, and then this is at 90 degrees. Okay, I've not done a very good job here, but even when you do it by eye, it's not going to be that accurate. What we need is our compass to do it. So let's give that a go. Here's what we do then. We get a compass and we put the points on the very left-hand edge. And then we extend it beyond halfway. It doesn't have to be like a certain measurement, just make sure it's like not here. It's not going to work if you do that. Don't make it like that, I wouldn't. Just make it go beyond halfway like this. And then I'm going to draw an arc around, a bit less than a semicircle. What this is showing is all the points that are the same distance away from this very end point on the left. If I then move my point here and do the same again, I'm now doing all the points that are the same distance away, but the same as the previous distance, it should be said. I've not changed the radius of the compass. It's going to look a bit like this. Okay, yours might not look exactly the same. If you make it a little bit bigger, then this little bit in the middle will be bigger, or smaller, it will be smaller. Now, what has just happened? These 2 points where they intersect are actually, now don't draw this bit in on yours, but they are the same distance away from their respective ends. So this length here is exactly the same as this length here. And it's also exactly the same as this length here and this length here. And you can see the horizontal line is now one of the diagonals of the rhombus. And if you draw in a vertical that goes through these 2 points, then you'll have the 2 diagonals. And we know from above that, first of all, they bisect each other. And secondly, they are at right angles to one another. So if I draw that line in, which I'm going to do now, it's easier for you to do it with the ruler perhaps than I'm doing on here. There we go. That line is necessarily, first of all, it's the diagonal of the rhombus. I've just got rid of the rhombus now, but it will guarantee that it splits the horizontal line into 2, and we've got a 90-degree angle. So there is your perpendicular bisector. Okay, you're going to practice this a few times. Like, you know, if I'm teaching this lesson live, then I'd give some handouts out and I'd say, like, have a go at some. So if you are doing this just by video, then draw some, draw another one, just practice this skill a few times. That would go for all the constructions I'm doing. Make sure you, like, I'm not going to make you make notes or anything on it, but just try and memorize it and try and understand why it works. I think that really helps, and it's, you know, you're not just learning a random thing. There's lots of maths going on in the background. Next one, stepping it up a bit. We're not finding the perpendicular bisector now. We are finding the perpendicular through a point on a line. It doesn't necessarily have to split it into 2. What I need to remember is my compass. Okay, this is what you do in this case. Get your compass, and this time, okay, you're going to need to make it so it's like between, or put the points on the cross, and then change the radius so it's somewhere between here and the very end. I would advise maybe about 3/4. And then I'm going to draw just a little arc going around. So this is a particular distance away. And now if I keep it on the point but bring it round and draw another little arc, then what I've just done, doesn't matter that this one's a bit bigger than that, what I've just done is I found along this smaller line that I've just sort of created, well, this distance is exactly the same as this distance. And what that means is that X is now in the middle of that smaller line. I can basically imagine cutting this off and cutting this off. I've made X the middle of my line, so I can now construct a perpendicular bisector, not of the original line, but of this smaller line. Amazing. Let's give it a go. So I'm going to put, now I don't want to touch that cross now, it's there, but I'm just going to sort of forget about it and do the perpendicular bisector of the other line. Just got to be really careful that you are putting the point in the right place. Okay, and then I put it on the left hand side. I'm going to draw my arc as I did before. 1 second, I've not extended it halfway, have I? So I need to, like, if you don't extend it halfway, it's not going to have this overlap we had before. So I need to make it a bit bigger. It's okay if I kept it the same, it's going to be exactly halfway. Actually, let me show you what would happen if I kept it exactly halfway. I'm going to get that, because it's easy to make this mistake. Then I'm going to get that, and they don't, I can't really draw a perpendicular bisector using that, so get rid of it, bring it back to here, and now extend it beyond halfway. Don't forget to do that. Okay, now draw the arc. Here it goes. Bring it round. Make sure it's on that very end bit. Okay, we've done exactly the same as before. We've created this, you can sort of might be able to visualize the rhombus. And it's actually okay at this point. You don't actually need both ends. You could just go from here to here and you've constructed a perpendicular to the point. If you want to extend it and go through there, that's absolutely fine. It's actually okay to just go from the point to somewhere on it though. That is a perpendicular to the given line through the point. I'll leave it at that. Actually, you know what? I really like to just do the whole thing. So yeah, let's do that. It doesn't look perfect, actually. I think that's because I'm doing it electronically. I should probably maybe just... It's quite hard to do it, but like yours should maybe look a little bit better than mine. All right, practice that again, and then we'll move on. How about, whoa, now the point has jumped up, it's slightly away from the line. How can we deal with that? A perpendicular that goes through that point away from the line. Now think about what we just did with the point on the line and see if you can do this one yourselves. Okay, well this is what you do. You again put your point on the cross. I'm going to try and be as accurate as I can there. And I'm going to bring it in so that it definitely fits on the line. Yeah, that does. And again, I am going to draw a little mark like so. I'm going to bring it round and I'm going to draw another little mark. And what I have done is I've essentially created an isosceles triangle now, because that distance there will be the same as that distance there. And essentially this, it's not in the center of the line, but it's like in the center of the line and then up a bit. And if I draw the perpendicular bisector now of this smaller line, it will necessarily go through that X. I'm going to get rid of the triangle, but what I'm again saying is that we can ignore, we can basically cross this out, and we can do the perpendicular bisector of this smaller line. To do that, get your compass points there again. I've already gone beyond halfway, pretty sure, so I'm going to draw a cross going round. It goes through it. That's okay actually this time. You could make it larger if you wanted, but bring it round. Lovely. And then finally, just get this line, and there we have it. We've managed to draw perpendicular through that point on the line. Good bit of maths there. So far, we've looked at constructing three different types of perpendicular lines. First of all, a perpendicular bisector, which uses the property of a rhombus, as we talked about with the diagonals. We've looked at a perpendicular through a point on the line. We just have to kind of, make it so the point is the middle of the line, and it's the same as before. And a perpendicular for a point away from the line, and it's very similar again to that second one. So if you got these two are very similar. So once you've got your head around one of them, you're probably okay with the other one. Right, we're now going to look at another construction, an angular bisector. So this is when you've got an angle and you are this time drawing a line that will split it into two. So this bit here is the same as this bit. It's like a little hedgehog kind of construction. And also, actually that's it. It bisects the angle. There's no other bit to it. There's no perpendicular bit to it. So let me get rid of the hedgehog for a second. How can we do that? Well, we need our compass. Got to make, and really important to keep it at the same radius as you're going through these things. Like as you're rotating your compass, and it can be easier to hold the compass in the same place and move the page around. Not when I'm doing it electronically, but for you it might be. Right, this one here. What do we do? Well, you start from the point. Just make sure you're exactly on the point, and then this time you draw an arc going around. What this is doing is making a point that's the same distance away from the center as it is as this one is. So they're the same. What we then do is we go up to where we've made the arc and draw another arc here. And then do exactly the same the other side. Like so. And what this is necessarily doing, again, don't draw this bit of it, but it's this, sorry, my laptop's just slowing down a little bit, back, here we are. All right, this distance here is the same as this distance here, and this distance, and this distance. So I have again essentially constructed a rhombus going on. And we've talked about the fact, well, in a rhombus, I didn't actually say this at the start, I don't think, but in this rhombus, if we then draw the diagonal in, it's going to necessarily, first of all, these are going to bisect. I didn't say this. These two angles are going to be exactly the same because you've actually got congruent triangles. If you look at the top triangle that I'm outlining here, it's going to be the same as that one there. And actually, even more so, this is going to be congruent to this. Let's just summarize. These two angles are going to be the same, which is exactly what we wanted. Going to get rid of those rhombus, but that is what's going on in the background. So all I need to do to finish this off is start from this corner and make it go through. Okay, it won't necessarily be horizontal this time because it depends how your angle is. So don't just draw a horizontal line. Just make it go through the cross and we're there. Okay, if you want to decorate it and make it look like a hedgehog, then you can. If that helps you remember it. So that's it. Try some of those. The angular bisector, again using properties of circles and a rhombus. One more key one, and then we're on to like some amazing ones, or an amazing one merely. All right. You could be asked to construct a triangle with sides exactly 4, 5, and 6 centimeters, leaving all construction lines. Now it's possible to have a go at this just freehand. You could make the base 6 centimeters and then you could maybe just try, oh, that's about 4, that's about 4, oh no, it doesn't quite work, or maybe you can make it work. But the precise way of doing it really is to use a compass. So I'm going to draw my line there. It's okay, it's absolutely okay to start off with one of the sides. And it doesn't have to, I would go with the longest one, but it doesn't have to be. So I've gone with 6 centimeters here. And then you grab your compass, and what you do is you bring it around. This would be the same thing if you had other sides, and then extend it to 4 centimeters exactly. It's pretty good. What I'm going to do is I'm going to draw around, just draw an arc that goes around. This tells me all the points that are 4 centimeters away. And it's just on that side this time, you don't do it on the other side. What you then do is that other side you've not done, in my case it's the 5 centimeters. There we go. And now on the other, actually not quite 5. Now on the other edge, other end I should say, do the same thing. Bring it around to here. And these are all the points that are 5 centimeters away from that right hand point. So along here, it's 4 centimeters away from this arc. Here, it's 5 centimeters away from that arc. Where they meet, it is both 4 centimeters away from the left-hand side and 5 centimeters away from the right-hand side. And I have necessarily constructed this triangle. 6 centimeters, 4 centimeters, 5 centimeters. You could have done it the other way around. That would have been absolutely fine. You could have started with the 4 centimeters and then done 5 and 6 centimeters. It doesn't actually matter. I'd start with the largest one, to be honest. And you can construct I'm just going to throw this as an extension. I want you to think about this. How could you construct a 60-degree angle using just your compass, ruler, and your pencil? We know how to construct 90 degrees, we've seen. We know how to construct a triangle. How can you construct 60 degrees? Well, this is what you can do. You can start out, basically we need to construct an equilateral triangle, which necessarily has all its angles as 60 degrees. So I'm going to make it 5 centimeters. And then I'm going to set my compass as 5 centimeters. And I'm going to keep it as 5 centimeters. There we go. Yes, it is already 5. Brilliant. And then I'm going to draw an arc going round. And then I'm going to move it to the other one and draw an arc coming back down. And then I'm going to connect it. And it must be that I've got, it doesn't quite look right, but I think that's because I haven't extended my arc the whole way around. I've created an equilateral triangle. I know that must have angles of 60 degrees. Let's just check it. I'm going to grab my protractor, scroll all the way back down for these ones we did. Really good constructions. Check it. And look at that, perfect 60 degrees. And you might want to think what other angles you could make. We've got 90, we've got 60. I'll leave that just as a little challenge. Can you think, how could you incorporate some of the skills we've used to make other angles? You might want to have a go at those. But well done on this. In a minute, I'm gonna show you one more construction that you can do. All right, this is where it becomes amazing. How can we construct a regular hexagon? That's the starting point. Okay, this is quite difficult to think about, so I'm gonna guide you through this, although you can think about it if you like. What you can do for this is construct, first of all, a circle with a given radius. You can decide what it is. And what we do is we mark off, I'm going to mark off the center because that will come back to that. Just make a little mark anywhere on your circle. So I'm going to put it there. And then with your compass point, put it on that little mark and then go around the circle and make the next mark. So what we know, what we actually know is that this distance here to this distance here is the same as the radius. Do the same again. Right, do the same again. Basically, just follow it all the way around. Try and be as accurate as you can. Keep going. Okay, last one maybe. When I get back to here, oh, well, it meets exactly where my original was. How does that work? Well, what I've actually created, if you've understood the equilateral triangle I drew, is that this is an equilateral triangle. All the sides have they're all the radius, but this is also an equilateral triangle, and you can actually connect them all up. And because they are they all have 60 degrees in them, when you put 6 of them together, it will necessarily give you a regular hexagon. You can see this angle around here is going to be 6 times 360. That all works, and actually the interior angle of a regular hexagon is 120. I get that from these as well. Now I'm going to get rid of these lines. I just put them in to illustrate like where the hexagon came from, but it's a really cool trick that you can do. Really a trick, a bit of maths that you can do. Construct using just a compass, ruler, and pencil a regular hexagon. Very tough to do it without a compass, I'd say. If you try and do that by hand, it's gonna, you'll be able to visually see that it doesn't look like one. I could even like rotate it to try and make it look like it's horizontal here. Let's go with that. Okay. What we can then do, we're not done actually, is we can draw a perpendicular bisector on each side of the hexagon. So you might want to actually make your hexagon a bit bigger. I'm going to make mine a bit bigger now so that it's a bit easier to do and it will actually look even better. So there we go. I'm going to make it that big. I'm going to have to change. Actually, yeah, I'm going to have to change my compass. So that's okay. I'm going to draw a perpendicular bisector on this very top line. Sorry, it's a bit harder to do for me because I can't scroll up at all. Right. I want to go beyond halfway. Remember that? That looks like it's beyond halfway. Yeah. But I might need to move it. Sorry, I need to just bear with me to move it down. Okay, then I think I'm just going to go a little bit beyond halfway, and then I'm going to draw my arc. Do it over here. Same again. Okay, try and be like I have not been very enough precise. The more precise you are, the better it will look at the end. So actually, I'm just going to challenge you: be more precise than me. Draw my arc here, and then I want you to draw the perpendicular bisector, and then do the same the whole way round. And what you can actually then do is you can connect the point that you got for your hexagon, you can connect it to where the perpendicular bisector meets the hexagon, like so. And what this is going to start forming is a regular dodecagon. When you do it all the way around, it's just going to connect and make a regular dodecagon. So you can pause the video now, have a go at this. I'm gonna keep going with it and see if I can get there. Okay, I got that one. It's going to keep going. Perpendicular bisector, that one. You can see that this would connect up to give a whole circle. I've tried to keep them separate. Okay, we've actually created 6 perpendicular bisectors. Well, I nearly have. I've just got to draw the lines in. Draw them in, not in purple. We're nearly there. Now, just finally connect. Hold on, is that the same purple? Probably. Okay, connect then the points to where the perpendicular bisector meets. And we have ourselves a regular dodecagon. You could even just like carefully delete construction lines now. If you went over the dodecagon with pen and you've been fairly soft with your pencil, it's very hard, you know, very like such a easy way in some respects of drawing a regular 12-sided shape you've got no hope of doing without a compass. And if you wanted, you could actually have repeated the same thing again. You could do a perpendicular bisector of, you still need your circle in there in that case, a perpendicular bisector of this side, and you could just keep going. It would end up like over here, and you could actually draw a regular 24-agon. That would look amazing on A3 paper, so do give that a go. But that is the end of our constructions for now. Okay, an amazing shape, amazing constructions. Hope you've enjoyed it. Well done.